Now on to some example problems. We've got this, we can do it. So here's our oblique triangle. Once again, this is just for writing stuff down. It is not drawn to scale. And here we have the first one. So A is 5 feet, C is 30 degrees, and B is 3 feet. So I don't know enough to do law of sines. I don't know enough to, that's the only one else I have. So I'm going to have to use law of cosines. So I know that c squared is equal to a squared plus b squared minus 2ab cosine of c. If you're actually trying to memorize this, just know that whatever you start with, that goes with the angle, and the other ones go in here. So that's how it works. If that doesn't help you, just write it down. It's completely fine. Don't worry about it too much. Now I'm going to use this to find side C. If I know side C, I can use law of sines, which is way easier for the rest. So c squared is going to be equal to a squared, which is 25, plus b squared, which is 9, minus 2 times 3 times 5, which is 15, cosine of 30. Okay? Now I'm going to plug this whole portion into my calculator and see what I get. So 25 plus 9 minus 30 times cosine of 30. Ooh, I like that. Symmetry. And I get that c squared is equal to 8.019. And the square root of 8.019 is a billion. Now, so c is equal to 2.831. Sorry, 2.832. There we go. So I got one of the sides now. Now I can use easier things to get the rest. So I'm going to use easier things. So a over sine of a, and we know that a is 5, so let's go ahead and plug that in, is equal to c, which is 2.832, over sine of c, which is sine of 30. And I can now solve for a. So I'm going to go ahead and do some algebra and figure that out. So times both sides by sine of a. That cancels. Looks pretty good there. And so I'm going to get 5 is equal to 2.832 over sine of 30 sine of a. Now I'm going to multiply both sides by sine of 30. So that cancels. As a note, I don't usually write these things out, but I want to go ahead and give you that practice right here at the beginning of the semester. As we move farther forward, I will do this less and less because I expect you to have mastered these intermediate steps. And finally, I divide that over, and so I get that this is 2.832 over here, and I got sine of a by itself on the other side. So I'm going to do sine to the negative first of 5 sine of 30. You can always plug that into your calculator and figure out what the exact number would be. I just didn't do it that this time. And that will give me a. And so what does a come out to be? Let's find out. Okay, shift sine, got that. 5 times sine of 30 divided by 2.832. That gives me 61, I'm going to just go ahead and say 62 degrees. Okay, so that was, what am I solving for? A, yes. So this one right here is 62 degrees. Now since I know two angles, I can go ahead and use the number of angles in a triangle to solve for the third. So 180 is equal to A plus B plus C. 180 is equal to 62 plus B plus 30. And I plugged into my calculator and I see that B is going to be equal to 88 degrees. Wonderful. Why did I use that instead of law of sines? That was a lot faster, in all honesty. And with this last angle, I can then solve for my last side. I could have done that beforehand, actually. But actually, wait a second. I think I know everything. I do know everything. Ha! I'm done. Okay. I know all my sides. I know all my angles. The problem is finished. Happy day. Okay, we got a few more to go, so let's try them out. So next one, B is 2.8, okay, 2.8. A is equal to 30. and C is 7 feet, what is A, B, and C? Now this problem is actually literally identical to the last one, just with different numbers. You can see that I know more or less these three things. I know everything on one side of my triangle. And I'm going to be law of cosines whenever you see that. But let's go ahead and do it. So A squared is going to be equal to B squared plus C squared minus 2BC cosine of A. Remember, this guy goes in the angle, and these two go right here. Otherwise, it's the same each time. So I plugged it in. I don't know what A squared is, but it's going to be equal to 2.8 squared plus 49. I know what C squared is. Minus 2 times 2.8 times 7 cosine of 30. I'm going to do this slightly different. I'm going to just plug this whole thing in my calculator. Actually, I know everything's here, so I'm not going to worry about it too much. I'm going to plug all this in my calculator like I did last time. Let's just make it easier. Simplify where you can, people. Simplify where you can. Okay, so 2.8 squared plus 49 minus 2 times 2.8 times 7 times cosine of 30. And so I get that A squared is equal to 22.89, and therefore A is going to be equal to, I take the square root of 22.89, and I get 4.78. Okay, so I've got A is equal to 4.78. Cool, let's put on my little diagram right here. Now I'm going to use law of sines to get one of the other angles. As a note, I could use law of cosines to solve for everything, but law of cosines takes a lot more effort than law of sines, at least for me. So I'm going to use law of sines. And I'm just going to find angle B. Why not angle B? Sounds good to me. So, whoa, did it again. There we go. So, let's see here. A, so 4.78 over sine of A, which is sine of 30, is equal to B, which is 2.8, over sine of B, which I do not know. Okay, I'm going to go ahead and plug all of this into my calculator and get one number. It'll just make it easier on me. And just do however it works for you. So 4.78 divided by 0.5, sine of 30 is 0.5. It's a good one to know. I think that's 9.56. It's going to be equal to 2.8 sine of B. Perfect. And so I'm going to go ahead and multiply both sides by sine of B. Okay, that cancels. I'm going to divide both sides by 9.56. And that cancels. And I get that sine of B is equal to 2.8 over 9.56. So I go ahead and plug in that shift sign in my calculator to get where the angle B will be. And what do I get? 2.8 divided by 9.56. So I get that B is equal to 17.03 degrees. Okay. Now I've got two of the sides. It's time to get the last angle. And I'm going to just use the fact that there's 180 degrees in the triangle to solve for the last one. So 180 is equal to A plus B plus C. And therefore, 180 is equal to 30 plus 17.03 plus C. So 180, I'm going to go ahead and subtract it off, minus 30 minus 17.03. I get that C is going to be equal to 132.97. Okay, so there we go. I got that one solved. I know absolutely everything now. We can move on to the next example. Let's just keep on powering through them. So C is 7 feet, okay. B is 2 feet, and A is 75 degrees. What is A, B, and C? Okay, let's try this again and keep on going through it. Did it right there? C, B, and angle A? Yes, I did. So this is pretty similar to last time. just with slightly different numbers. So, a squared is equal to b squared plus c squared minus 2bc cosine of c. Oop. Not cosine of c. Cosine of a. There we go. I was just thinking to myself, do I have this memorized or not? Apparently I make mistakes. That's okay. Now, with that in mind, we have all of those looking really good. So now what we're going to do is we're going to go ahead and plug in our numbers. So a squared is going to be equal to 4 plus 49. I can just do 2 squared is 4, 7 squared is 49, minus 2 times 2 times 7 cosine of 75 degrees. I'm going to plug that in my calculator to see what this is. I'm going to plug all this in and get what I get. So 4 plus 49 minus 2 times 7 times cosine 75. And I get that a squared is equal to 45.75. 45.75. And therefore a is going to be equal to the square root of that. And that comes out to be 6.76. Okay, so I got one more side. So now I'm going to do the exact same thing I did last time, which is to use law of sines to solve for an angle. And then from there I can keep on moving on. So I'm just going to solve for angle B. I'll do angle C this time. I did angle B last time. So 7 over sine of C is equal to A, which is 6.76, over sine of A, which is sine of 75. Okay, I'm going to multiply both sides by sine of C to get it on the top. Okay, that cancels. Good. And now I'm going to do one more step. I'm going to divide both sides by 6.76. Okay. So that one cancels. And I'll go ahead and do all of it. And we'll multiply both sides by sine of 75. There we go. So that cancels. So this side just has sine of C now. So what I get is that sine of C is equal to 7 sine of 75 degrees over 6.76. And so I plug it in, shift or second sign to get sine of the negative first of that value. And so C is equal to, let's find out, 7 times sine of 75 divided by 6.76. Did I plug that in right? I did. To plug everything else in right. I'm getting a really weird number. It's actually giving me an imaginary answer, which is not good. I should not be getting imaginary angles. So, something has gone horribly wrong. Okay. Let's see here. Go ahead and clear the slide. So for this one right here, something has gone wonky with it. And I'm guessing that might be that my numbers are way too far. Let's see, this was 7, this was 2, and this was 75 degrees. So most likely what I gave was an impossible triangle here. So that's good for me to know. This one right here is actually impossible, so long as my math before was right. If you saw a mistake in my solution, you can let me know and I'll fix it there. Most likely I gave an impossible triangle possibility. So sometimes it doesn't matter if you have the right values or the right possible numbers are going to if you have numbers, it doesn't mean they can make a triangle. For example, a really easy way to see this is, let's see here. If I have A is equal to 10, and B is equal to 2, and C is equal to 7, you got three sides here. But if you were to try to make this into a triangle, what you would see is that this is A, and B and C have no ability to connect, because B goes, C goes that far, and B goes this far, but they don't actually connect. There's this gap here. So it doesn't mean that every single possibility can work for you. Okay, we'll do that last example, and then we're going to call it good for today with this one. So if A is equal to 3, B is equal to 4, and C is equal to 5, what is A, B, and C? This is a very common triangle. So 3, 4, and 5. So that's 3, that's 4, and that is 5. And I'm just going to go ahead and tell you that this is actually a right triangle. How do I know that? Because this is a really popular one. 3, 4, 5. It's done a whole lot. Now, you don't know that yet, so we're pretending like we don't know that. And we're going to go ahead and solve it as if we didn't know that, okay? But just so you know, we're going to solve for angle C first, and it's going to come out to be 90 degrees. Exactly. So what do we have here? Well, we have C squared is equal to A squared plus B squared minus 2AB cosine of C. 25 is equal to A squared plus B squared, which is 9 plus 16, minus 2 times, make sure I do all this right, 3 times 4 cosine of C. Well, what you get then is that 25 minus 25 is 0, so 0 is equal to negative 2 times 3 times 4 cosine of C. I'm going to divide both sides by this value, and I just get that cosine of C is equal to 0. And that means that C is equal to 90 degrees. Oh my goodness, this is a right triangle. Happy days. And since it's a right triangle, we can actually use all of our trig functions to solve for the rest. So if I want to, rather than doing it the hard way, I can find these other two angles using cosine and sine if wished. So I'm going to go ahead and do that. I'm going to find this angle now. And I know that cosine of this angle, cosine of, with how I've drawn this, I'm really confusing myself. I'll make sure I do this right. This is A, this is B. There we go. Okay. So this one right here would be, yeah, I'm doing okay. So this is angle A, and this is angle B. Okay, so cosine of B is going to be equal to let's see here, yes. Cosine of B is going to be equal to 4 over 5. I just lied to you, 3 over 5. So B is going to be equal to cosine to the negative first of 3/5. Turns out to be 53.1 degrees. Okay, so we have this angle, 53.1. Let's find the last angle, and we know that 180 is equal to A plus B plus C. So 180 is equal to 90 plus 53.1 plus A. And I solve for that. And I get what? I get that A is equal to 36.9. There you go. It's really a happy accident when it comes out to be 90 degrees. Isn't that nice? Okay, so we practiced. We've seen how to use law of cosines. We've also seen what happens when we have examples that aren't real. You will get imaginary values for angles if you have something that is not possible. Beyond that, Thank you all for listening, and I will see you all next time. Bye-bye.